Hello, everyone. Welcome back to day 3 of hypothesis testing. Uh, Previous two videos, we saw a run through of the hypothesis testing process. So far, with three different examples, we've seen a left tail test, a two tail test, and a two tail test in the most recent example. And we also talked in detail about some of the logic behind how to set up the null and the alternate hypothesis. So what we're going to focus on today, I'm not going to do another run through of a hypothesis test. I think we've seen enough of those for the week so far. What we're going to talk about today is kind of what happens at the end of the test. And this is where we determine the type of errors that can be made with hypothesis testing. What I mean by that is our hypothesis test leads us to certain conclusions. So once we have ran the test and we come to a certain conclusion, there is a possibility that the conclusion we come to is wrong. Okay, so we might assume something about the alternate hypothesis when the alternate hypothesis was wrong. Okay, so these are the type of errors that we're talking about. So there's two types of errors that we need to be on the lookout for. These are called type 1 and type 2 errors. Now, this little chart that I have over here on the right, there is a link where you can download this in full size. So I would recommend that you print that out and kind of have that out with you as we go through these notes. So that you can kind of think about the different types of errors that occur. You're really going to want to know this chart. And as you go through the homework, I would also have this out and just kind of practice like, okay, we're rejecting the null, but the null is true. And just really make sure that you understand it because students trip themselves up on this thing all the time. All right. So let's take a look at this first scenario here, and we're stripping away numbers and everything else. We're just looking at a scenario and creating a null and an alternate hypothesis to analyze the different types of errors. Okay. So in this first one, you have to imagine that you want to go skydiving. All right. One of the common fears associated with skydiving is that your parachute is not going to deploy and you ultimately fall to your death, right? So you jump out of the plane and the parachute doesn't go off and you're done. All right. This isn't a very likely thing to happen. In fact, it rarely ever happens, but it is possible for it to happen. Okay. So in this situation, we're going to come up with a null hypothesis. It's generally assumed that your parachute is going to deploy. It's going to go off. Right. This is what happens. Assumption about the population of parachutes is that the parachute's going to work just fine. All right. The contradiction to that, or the alternate hypothesis, is going to be that the parachute does not deploy correctly. Right. And that would be bad. Okay. So let's say we run our hypothesis test. We're standing here making a decision about whether or not to go skydiving. And let's say that we reject the null hypothesis. Okay, so we're going to reject the null hypothesis, which means we reject the idea that the parachute's going to deploy. So we have made a decision. If we are going to assume that the parachute's not going to work, we're not going skydiving. Okay, so if we're rejecting the null hypothesis, we're not going skydiving. Okay. So let's say we make the decision to not go skydiving based on the results of our hypothesis test, and somebody else grabs our parachute, decides to go skydiving, and they jump out of the plane, and the parachute does actually deploy, right? So we rejected the null hypothesis. We made this decision to not go skydiving, and we probably should have. We should have went skydiving because the parachute was going to work. Okay, so this is what's called a type 1 error. The type 1 error in the outcome here is that we didn't get to go skydiving. Okay, so we miss out. Right, but we live. Right, it's not the worst thing in the world. We missed out on skydiving, but we do live, which is a great thing. Okay, so that is a type 1 error where we reject the null when the null is true. Okay. So in the second scenario, again, we've made the decision not to go skydiving. We're rejecting the null hypothesis based on all of the data presented to us. And in this situation, somebody says, okay, well, I'm going to use your parachute. And they go and they use your parachute. They jump off the plane and the parachute does not deploy. Well, guess what? We made a good choice, right? So this is a correct outcome. We made the correct choice in this situation. So correct outcome here, and we live. Right? So this is good. This is why we do hypothesis testing, is so that we can make those correct choices. All right. So now let's think about this from a different scenario. This time we're going to fail to reject the null hypothesis. So we've analyzed all of our data. We're standing there at the plane, and we fail to reject the null hypothesis, which means we're gonna assume that the parachute is going to deploy. So in this scenario, we are going skydiving. We have made that decision. We are going skydiving based on the results of our hypothesis test. All right. So we go skydiving, we put our parachute on, we jump out of the plane, and the parachute deploys. So this one is a correct outcome. We made a good choice. We decided to go skydiving, and the parachute went off, and everything went great, and we had a great time. Okay, so the outcome here is had fun and lived. Okay, so I'm trying to give you the outcomes of these scenarios in the context of the problem. Okay, and what we're really looking at is every possible way this could turn out. So the last situation here is we decide to go skydiving, so we fail to reject the null hypothesis, and we decide to go skydiving, but the parachute does not deploy. This one is a type 2 error. A type 2 error, and the outcome here is you die. That's not good. All right, so type 2 error would be the one where you decide to go skydiving and the parachute doesn't work, right? So you decided that the parachute would work and it ended up not working. That is a type 2 error. Okay, so in this scenario, as with any scenario, it doesn't automatically mean that a type 2 error is always going to be the worst type of error compared to a type 1. It just depends on the specificities and the scenario in which you are dealing with, okay? In this particular scenario, obviously, type 2 is the one that you want to avoid at all costs. So you would do everything in your test to make sure that you minimize the probability of a type 2 error. Okay, so we want to minimize type 2 here. And believe it or not, there are ways where you can control for the probability of a type 2 error. So you can minimize that probability. So it's more of a topic if you want to minimize type 2 probabilities. That's more of a topic for advanced and later statistics courses. Okay. And if you look over here at our chart, you can see that the probability of a type 2 error is considered to be beta, which is a weird it's a weird variable. You can figure it out, but like I said, to figure out what beta is, it's more of a topic for an advanced stats course. Now, the probability of a type 1 error is very easy to find, as it's equal to the significance of your hypothesis test. So if you're running your hypothesis test at a 5% significance level, the probability of making this particular error is 5%. Okay, so that's a really cool thing. So we can actually very easily calculate type 1 errors. Type 2 errors, a little bit more complicated to do. All right, so just keep that in mind. Also, other names that they give for the different types of errors, so like the type 1 error is one that we call a false positive. So if you can imagine like going to get drug tested or something like that, and it says that you took drugs when you didn't. Okay, so that would be an example of a false positive. A false negative would be you go and you get drug tested and you do drugs, but it didn't catch you. All right, so that would be a false negative there. A little bit harder to calculate that particular probability. All right, so let's look at another scenario, and I'm going to bring my chart down here with us. And we'll look at this one. This one relates more to the justice system and what we do there, like when you go to court to defend yourself. So when you are accused of a crime, you have to go to court and defend yourself, and the burden of proof actually lies on the prosecutor. They have to prove that you are guilty beyond all reasonable doubt. And when you walk into that courtroom, you have presumed innocence. Okay, so they don't assume that you're guilty; they assume that you are not guilty. right? And the two outcomes of any court case are guilty or not guilty, right? So that easily sets up our null and our alternate hypothesis. So the assumption is that you are not guilty. The alternate or the contradiction to that would be that you are guilty. Okay. So you go through your court case, everyone presents their evidence, and at the end of the court case, let's say the jury decides to reject the null hypothesis. So we're rejecting that you're not guilty, which means the outcome here is guilty. We are making the decision that you are guilty as charged. All right. So if we decide that you are guilty, but you're actually not guilty, that is a type 1 error. Okay. And the outcome here is that an innocent man goes to jail, right? Or an innocent person goes to jail. Right? And that would not be good. We don't want innocent people to go to jail. You don't want to go to jail if you didn't commit a crime. Okay. So, again, starting over, we present all of our evidence. The jury reaches the decision. They decide that you are guilty. They are rejecting the null hypothesis. So, you are guilty. And you actually are guilty. Okay. So, guilty, when you actually are guilty, this is a correct outcome. Correct outcome here. Good. Okay. So, a guilty person goes to jail, which is what should happen. Okay. All right. Reset. So we go back, we present all of our evidence, and the jury decides to fail to reject the null hypothesis. So we fail to reject this, which means we're going to deem you not guilty. Okay, so this is the jury's decision here. So they have decided that you are not guilty, and you actually are not guilty. You actually did not commit a crime. Okay, so in this case, this is a correct outcome. Right, the jury decided that you're not guilty. You were actually not guilty, so that's good. Right, so this is a correct outcome. And in this situation, an innocent person goes free. Okay, and that's good. An innocent person should be free. All right. So reset. We present all of our evidence. The jury decides you are not guilty, and you actually are guilty. Okay. So they reached a verdict of not guilty. You actually were guilty. You did commit the crime. All right. So this is a type 2 error. Type 2 error. And in this situation, a guilty person goes free. Okay, this would not be good. So those are the two types of errors that can happen, let's say, in a court case. So we have the possibility that we could send an innocent person to jail. Then you have you have the possibility that you could let a guilty person go free. And the question is, which of these two errors is considered worse? All right. So in our criminal justice system, it is actually the type 1 error that is considered to be more egregious. In other words, this is the one that they try to avoid at all costs. We do not want to send an innocent person to jail and strip them of their liberties when they don't deserve that. All right, they would rather let this happen, and you can be the judge of whether whether or not you agree with that. But this is the one that our criminal justice system supposedly tries to minimize at all costs. Right, so type 1 error, we want to avoid sending innocent people to jail. So you can see that different scenario leads to a different type of error being the worst type of error. Okay, so it just depends on the situation. And when you look at your hypothesis test, you look at the situation and you decide which error is it that I need to minimize the most, and you would design your test around minimizing that error. Okay, so like I said, you can calculate the probability of a type 1 error by setting your significance level to be really low. So if you wanted to minimize a type 1 error, you might reduce the significance of your test to 1% or even 0.5%, just to make sure that you are not going to make a type 1 error. Okay. Typically, a type 2 error, the easiest way And again, this is for a separate statistics class, but one way that you could reduce your type 2 error is to increase your sample size. So an increase in the sample size could lead to a reduction in your type 2 error probability. Okay, so that's your rundown of your type 1 and type 2 errors. I would highly suggest you watch through this as many times as you need and listen to that discussion and make sure that you read this chart very carefully and practice the problems while reading this chart. Practice going through the different scenarios, rejecting when it's true, rejecting null hypothesis when it's false, so forth and so on, and look at those scenarios. And there's a few questions in the homework that'll give you a chance to practice identifying type 1 and type 2 errors. All right, so that's it for this video. Good luck on the homework.